Okay, let's start off looking at number 31 on page 146. As you can see, this is going to be an opportunity to use the chain rule. I'm going to rewrite it to make it a little more obvious. And so I'll use parentheses and raise everything to the 1/2 power. And then on the inside of the parentheses, I have a 10 raised to the 5 minus y. Now, there's a lot of chain rule going on here. We have the outside function, which is this 1/2 power here. And then we have an inside function, which is an exponential. And then a very inside function, which is 5 minus y. So we have to use the chain rule on all of them. So the derivative, f prime of y, is going to equal 1/2 times whatever's inside the parentheses to the negative 1/2. Well, inside the parentheses we have 10 raised to, let's use that third color, 5 minus y. All right, now we multiply by the derivative of what's inside the parentheses, because we've already taken the derivative of the outside when we said 1/2 and lowered the exponent by 1. So the derivative of the inside is going to be natural log of 10 times 10 to the 5 minus y. Now that we have that derivative taken care of, we multiply by the innermost derivative, which is just going to be the derivative of 5 minus y, which will, of course, be times negative 1. So that very long derivative is your final answer. And if we wanted to simplify it, I would put that negative in front, put the square root back on it. Well, I'm sorry, we would have the negative would be in the denominator. I'm sorry, the square root would be in the denominator. So it would be square root of 10 to the 5 minus y. And up top we'd have the natural log of 10 times 10 to the 5 minus y. Man, that was a lot of work. Okay, let's take a look at number 32. Okay, so for number 32 we have to use the quotient rule. So I'm going to rewrite the top as z to the 1/2 over e to the z. And now it's just a pretty straightforward quotient rule. So low d high, e to the z times 1/2 z to the negative 1/2 minus high d low, z to the 1/2 times e to the z, because e is its own derivative, over e to the z squared. And that's it, and you're done with that one. Let's take a look at 33. Okay, 33 is y equals root z over 2 to the z. Okay, now this one's going to look a lot like the other one, except now, instead of dividing by e to the z, we're dividing by 2 to the z. So once again, I'll rewrite it as z to the 1/2 over 2 to the z, so that the derivative y prime is low d high, so 2z times 1/2 z to the negative 1/2 minus high d low. And remember, the derivative of the bottom now is going to be the natural log of 2 times 2 to the z, all over the square of what's below, which would be 2z quantity squared. Except I shouldn't have put that underneath the y prime. Okay, so that's number 33. I'm just getting warmed up. Let's take a look at number 34. Okay, so 34 is now, or it's getting a little bit more complicated. Y equals x squared plus 2 over 3, and the whole quantity is squared. So now I've got the chain rule and the quotient rule. So this will be fun. So I'm going to take care of that outside function first. So I'm going to have 2 times the quantity, x squared plus 3 over 3 to the first power. Now, having done the outside function, which was this exponential, or I'm sorry, this kind of raising everything to the power of 2, I'm now going to multiply by the derivative of the inside, which is going to be the quotient rule. Now, you could get away with not doing the quotient rule by thinking of the inside as x squared over 3 plus 3 over 3, which would just be x squared over 3 plus 1, which really might be the way to go. But since I've already said I'm going to use the quotient rule, let me continue with that. So it's just going to be low d high, which would be 2x, minus high d low. Now the derivative of the low, the derivative of the denominator, is just 0. So that whole part here is going to drop out over the square of what's below, which will be 9. So if we want to simplify this, we're going to get 2 times x squared plus 3 over 3 times 6x over 9, which you could definitely simplify further, but you get the idea. Okay, on to 35. 35 is, I'm going to rewrite it right off the get-go as x squared plus 9, x equals, over x plus 3 to the 1/2. Okay, so now we have chain rule, and we definitely have the quotient rule inside the chain rule. So y prime is going to equal 1/2 x squared plus 9 over x plus 3 to the negative 1/2 times the derivative of the inside, which is, of course, the quotient rule. So low d high is x plus 3 times 2x minus the high d low, and the derivative of low is just 1, all over the square of what's below. And Naomi, you just don't move any further and just turn in that whole mess. That's your derivative. Okay, we're on to 36. And yick, look at this thing. Y equals e to the x minus e to the negative x. They're just trying to be confusing. Over e to the x plus e to the negative x. All right, let's just roll up our sleeves and slog through the quotient rule again. So low, e to the x plus e to the negative x, d high, which is going to be e to the x, minus e to the negative x times negative 1, because this is negative x, so we have to multiply by its derivative when we're taking the derivative of the top, because we're using the chain rule on that second e, that e to the negative x. So we get e to the x minus e to the negative x times negative 1. Okay, now we're going to subtract low d high. High d low. So that's going to be e to the x minus e to the negative x times e to the x plus e to the negative x. I'm going to squeeze it in here, times negative 1 again, because of that exponent, that negated exponent, keeps giving us that negative 1 when we take the derivative. All over the square of what's below. E to the x plus e to the negative x squared. All right, 37. I can hardly wait. Let's take a look at that. All done with your own personal video here. Y equals 1 over e to the 3x plus x squared. The derivative there is going to be, well, we could get fancy and we could use, we could rewrite this, if you wanted, as e to the 3x plus x squared, all raised to the negative 1 power. And that's going to be a pretty quick way to do it. So I think, because this video is probably getting long, I'm going to do it that way. So my outside is going to be negative 1 times e to the 3x plus x squared raised to the negative 2 times the derivative of the inside, which is just going to be e to the 3x times 3 plus 2x. So that again is just the chain rule. Okay, now from your email it said you looked like you were having trouble with the knowing which rule to use, and I think you're referring to the fact that you understand that the derivative of cosine is minus sine, and that the derivative of sine is cosine, but it was a little bit more confusing as to when to use the product rule, when to use the quotient rule. If you have specific questions, I'll be happy to answer, but I hope maybe going through these chain rule problems and the quotient rule inside the chain rule maybe will help things. All right, Naomi, thanks for your email. I hope this helped a little bit.